Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about comparing linear, quadratic, and exponential functions. So we've already learned about each of these types of functions. We're just going to get a little bit more in depth about how they are different from each other. So a linear function is going to form a line, and then the equation that you probably most remember is y equals mx plus b, where m is your slope and b is your y-intercept. If your slope, m, is greater than 0, it's going to be a positive line, which means from left to right, it's going to go upward. And if my slope is less than 0, it's going to be a negative line, which means from left to right, it's going to go down. An exponential function, which is y equals a times b to the x, if a cannot be 0 and b cannot be 1, and b has to be greater than 0, okay? So if a is greater than 0, and b is between 0 and 1, it's an exponential decay. If a is greater than 0 and b is greater than 1, it's an exponential growth function, okay? And they kind of curve from left to right, it curves up if it's exponential growth, and from left to right, it curves down if it is exponential decay. And then a quadratic makes the shape called a parabola, which is that U-shaped curve, okay? And the equation is y equals a x to the second power plus bx plus c, where a is not allowed to equal 0. If a is greater than 0, it's going to be a positive parabola. It's going to look like a happy face. And if a is less than 0, it's going to look like a frowny face. It's going to be a negative parabola. All right, so 3 cars start traveling at the same time. The distance traveled in t minutes is y miles. Complete each table and sketch all 3 graphs. In the same coordinate plane, compare the speeds of the 3 cars. Which car has a constant speed? Which car is accelerating the most? Explain your reasoning. All right, so if I plug in this first equation, y equals t. So my y equals whatever my t value was. So these are just going to match. Okay. For the next one, I have y equals 2 raised to the t power minus 1. So I would do 2 raised to the 0, which is 1, minus 1 is 0. 2 raised to the 0.2 minus 1 gives me 0.15, and I did kind of round these. 2 raised to the 0.4 minus 1 gives me 0.32. 2 raised to the 0.6 minus 1 gives me 0.52. 2 raised to the 0.8 minus 1 gives me 0.74. 2 raised to the 1 gives me 2 minus 1 is 1. And then I'm going to do y equals t squared. So I'm going to take my t values and square them. 0 squared is 0. 0.2 squared is 0.04. 0.4 squared is 0.16. 0.6 squared is 0.36. 0.8 squared is 0.64. And 1 squared is 1. And so now I have all these ordered pairs, and I can graph them. So I'm going to do my linear function first. Okay, so that one is increasing at a constant speed, constant rate. So that is a linear function. Then I'm going to do my exponential function, and plot my points. Okay, and that one kind of starts to curve. And then your exponential function is always going to outgrow everything as time goes on. And then our quadratic function starts to make that U shape. Okay. All right, how can you compare the growth rates of linear, exponential, and quadratic functions? Which type of growth eventually leaves all the other 2 in the dust? So we kind of already said exponential functions are always going to exceed, if all of them are positive, it's always going to exceed the other types eventually, okay? But if you looked at ours, it looked like quadratic was kind of winning, but eventually the exponential would have went way beyond it. Linear functions are always going to make a line, quadratic functions are always going to make a parabola, and exponential functions will eventually outgrow the others. All right, so then here we have in table form a linear function. We have y equals 2x plus 5, so you can kind of see the x values are just increasing by 1 every time. And then you can see the pattern that's happening with the y values is it's increasing by 2. Okay, so the y values have a common difference of 2. With an exponential function, I have y equals 4 times 2 raised to the x. My x values, again, are just increasing by 1 every time. But my y values are being multiplied by 2 every time. So these have a common ratio of 2. Okay, so if you're multiplying or dividing every time, it's exponential. If you're adding or subtracting every time for your y's, then it is linear. And then quadratic functions are a little different. I have y equals x squared plus 2x minus 1. My x values are just increasing by 1 every time. But my y values are, at first, it's going minus 1, then plus 1, then plus 3, then plus 5. But the second difference, to go from negative 1 plus 1, we added 2. Okay, so my second differences are constant. So if you notice that in the table, then it is a quadratic function. All right, that's it.